This lesson is all about work. And work is equal to a force times a distance. So unlike what you might think of as work, which might be me making this lesson or you doing homework in physics, work specifically means applying a force over a distance. So one way to think of this is with a car. And when you have a car, you have a little engine, and that engine applies a force to the wheels and makes the car go forward. So as long as you have your gas on the accelerator, you are doing work because the engine is applying a force and the car is going a distance that the engine is applying that force. Now once we take our foot off the gas and the car starts coasting, once the car starts coasting, we're still going a distance, but there is no force being applied. Therefore, the car itself is not doing work. Okay? Over here we are doing work because we're applying a force over a distance. Now, the units for work are pretty straightforward. Since work is equal to force times distance, and force in metric system is newtons, and distance is meters, then our work is measured in Newton meters, which is equal to a joule, which is equal to the symbol J. So that's how we're going to measure it. And you always need to make sure that your units are newtons and meters before you calculate work. Otherwise, this will not be your unit. So a really simple way to think of this, work equals force times distance, would be like if you were applying a 10 newtons of force on a block or whatever that you're pushing across the surface for 2 meters, then we would just plug these numbers into the equation. We'd say work equals 10 newtons times 2 meters is equal to 20 joules. How easy is that? So what you're going to do for a fun little activity is measure how much work it takes for you to go up a flight of stairs. So the force is going to be the force that lifts you up, which is going to be your weight. All right? So your force in this case is going to be equal to your weight. But we're going to have to convert your weight into newtons. So we know our weight in pounds. So let's say that you weigh 100 pounds. And let's say that we know that 4.4 newtons equals 1 pound. Well, all we have to do is do 100 times 4.4, and that would give you your weight in newtons, which would be, what, 440 newtons. So then all we would have to know is what's the distance. So let's take a look at that. So your distance is going to be how far up you go. So here's our flight of stairs. And we can only consider this as being part of our force because gravity is pulling you down at your weight, which is 440 newtons in this case, in our example. And to go across this way, there's really nothing resisting you. I guess there's a little bit of air resistance preventing you from going forward, but very, very little. And so you've experienced this because it takes very little energy to walk across a horizontal surface, and it takes a lot of energy to walk uphill. So the reason is because your weight is what's taking all of that energy. So what we need to know then, since work equals force times distance, and we already know the force, that's this guy over here, we need to know the distance. So we need to know the height of the stairs. And your teacher should be able to provide that to you. That's going to be our distance. Once you do that, you can go out there and go up the stairs and go ahead and calculate your work. So to summarize, work equals force times distance. The units is joules, as long as you're using newtons and meters for your units and work. And the key idea, the strangest thing I guess about work, is that you have to have a force and you have to have a distance. You're doing zero work if you're just standing here holding up a box, even if it has a mass, or sorry, even if it has a downward weight of 10,000 newtons. That's no work because you're holding it in place. And there's no distance being applied. All right, good luck.